Hello, this is our video for Monday, 4/20. I should probably, normally I would do 9.2, the section 9.2 before this, but I'm going to jump ahead to 9.3 because it's relevant for our project, and I want to get into how to use Minitab to do the calculations you need for the project a little bit earlier. So my plan is to talk about the particular stat test for 9.3 today, and then next class do kind of a sample project so you can see what it is, and then you'll have about 2 weeks to do the project. Once you get the data into Minitab, it's pretty quick. You can, as you'll see when I do a practice project on next day, you can pretty much do the whole thing in like half an hour, and most of that time is just fiddling the data to get it properly into Minitab. And then it's easy to run once you're in there. So today, we're going to be talking about comparing two groups. So we compared the proportions in two groups, last week sometime, and now we're going to be comparing the mean in two groups. And 9.2 is also comparing a mean in two groups, but in that one, it's like you're taking two different measurements from the same person. And I'll explain a little bit more what I mean there. So, but if you're taking two measurements from the same person, then the variables in the two groups are certainly not independent. Here, somehow the idea is supposed to be that you separate into two groups, and the subjects in one group have no connection whatsoever to the subjects in the second group. Their only connection is that you're measuring the same type of variable on both of them. And then there's some other characteristic that we're using to separate them into groups. So let's first do an example where we have summary data, and then I want to do a couple examples where we pull data from a file that I have posted on my website. So first question, does sleep efficiency relate to high blood pressure? Okay, so this is an example I pulled out of a textbook, not our textbook, some other textbook a couple of years ago, and we have the data here. So in this example, 238 subjects age 13 to 16 are classified as high or low efficiency sleepers. So, maybe if you sort of toss and turn all night, you don't get as good sleep, that you're a low efficiency sleeper, like your sleep results in less rest. Someone who sort of sleeps deeply, maybe they sort of get more out of their sleep. So we have the high efficiency sleepers and the low efficiency sleepers. The number in the high efficiency group, I like to use lowercase n there. We'll leave it as lowercase n. There are 177 of those. And in our sample, in the low efficiency group, there are 61. And I think that adds up to 238. So the sample mean in the high efficiency group is a blood pressure of 112.6. So I guess blood pressure is normally two numbers, so that's sort of the top number. And in the low efficiency group, we have a higher blood pressure. But is that enough higher to be significantly different? Or is it just that we got lucky or unlucky and our 61 people happen to have high blood pressure for some other reason other than their sleep patterns? That's what we're testing. So the sample standard deviation matters for how these compare, and that's 7.5 and 9.9. So what we're going to do is we are going to run a hypothesis test comparing the two groups. Our null hypothesis is that the means are equal. Okay, so in our sample they weren't equal, but the null hypothesis that we're always going to use in these is that the two groups have the same mean on the quantitative variable that you're measuring. And then our alternative hypothesis is that they're not equal. is that the means are not equal. Okay, now I could pick a direction here, like maybe we could say if you get bad sleep, maybe you're bad in blood pressure, so high blood pressure. That would be reasonable, but I'm pretty much going to use not equals all the time for these. So let's get these numbers into Minitab. I'll flip over to Minitab. So in Minitab, this is going to be a 2-sample T. So we're comparing two groups. We're comparing the same variable, but we've split our sample into two groups, and we're comparing the two of them. All right, so I don't have the sample data in my table below. What I have this time is the summarized data. So in my first group, the high blood pressure group, the sample size, the number in the sample is 177. The sample mean was 112.6, and the sample standard deviation was 7.5. In the low blood pressure group, there were 61 individuals. They had a mean of 118.4, and the standard deviation was 9.9. So let's look under options. You can find a confidence interval for the difference. It looked like group 2, the low group, had a higher number, but you always do group 1 minus group 2. So it looks like the difference would be some negative number, about maybe 6 blood pressure units. But we could find a confidence interval to see where we think that number would be. I don't like to do confidence intervals for these two group things. I mean, confidence intervals do give you more information, but it's just tricky interpreting the number. And we have limited time left in this class because of missing a week. So I'm not going to bother with confidence intervals for 9.3. Hypothesized difference is 0. Our null hypothesis is that there's no difference, and our alternative hypothesis has a non-equals. This assume equaled variances, I am typically going to not check that. That's like the pooled versus not pooled that we had last time we were comparing two groups. That was categorical then. Do we say that the two groups have the same standard deviation when you look at the whole population? Or do you assume that maybe the groups actually have different standard deviations? And I like to say that they could be different. These groups are different for a reason. Maybe they are genuinely different, not just in their means, but also their standard deviations. But you could check this off, and that would be the pooled thing, where it sort of takes the two groups and combines their standard deviations to sort of one combined standard deviation. And if we had the data, it would find the standard deviation for all the data put together. But I'm not going to check that off. So let's hit OK and run our hypothesis test, see what we get. All right, so those are the numbers we all plugged in. And it looks like our difference was that group 2 was bigger by 5.8, and then we have a confidence interval for that difference. That's not what we were asked for. What we were asked for is this p-value, and it looks like it's small. It's 0 to many decimal places. Looks like you get into the 5th decimal place. So the 7 is in the 5th decimal place. The previous decimal places are lower. P-value equals 0.00007. So that's less than 5%. We have strong evidence of a difference between the two groups. Okay. Yep, so that's pretty much it. You just sort of have your two groups, you're comparing their means, we're running a hypothesis test to see if there's a difference between the groups, and we get our p-value. If that's small, it means there's a difference. If it's not small, then we do not have strong evidence of a difference. All right, so let's move on to the next example in a separate video.